दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. Today's class we will be discussing about the mechanism of chemical reactions involved in organic chemistry. So what is this word mechanism? Reactants react to produce the products. So reactants are definite compounds. So also the product form, they are definite compounds. But this formation of product from the reactant, what is the path that takes place? How the reactants produce the product? Means what? In a reactants, they are undergoing chemical reaction, the substances undergoing chemical reaction are called the reactants. So the cleavage of the covalent bonds take place in them, and formation of new covalent bonds take place. So how the bonds undergo cleavage and how the bonds that take part in the formation of the bond take place, that process is called as the explanation of that process is called as mechanism. So this mechanism which we are going to discuss today, they are the imaginary paths. They are hypothetical in nature, but there is a logic behind this. Logic behind this. Suppose one simple example I can give you. When we meet a person, and who becomes our real friend in life, he doesn't become the real friend in our life instantaneously. When we meet him, we see him, or he sees us, he will see us. Then the moment I see a person, some thinking comes to my mind. So if a recorded phase of video recording is taken of my earlier phase, before meeting a person, after meeting a person, while meeting a person, if recording is done, there will be some change in my eyes, in my nose, in my total face. Then after formation of when we meet and become friends, when now the face is recorded, it will be different. So here I mean to say here that we do not become a friend of somebody from one place to the other place. This happens too, but in between we have some changes in us. That is called, I get introduced to him, he gets introduced to me. Then we exchange our views. Different days they pass on, different phenomena, events that take place, and at last that may result in the formation of a friendship which remain for forever, or we may not become friends, just we become acquaintance. Exactly same thing happens in chemical reactions. So that intermediate positions are called as the intermediates. So here also some reaction intermediates are formed, and those reaction intermediates are very reactive spaces. So those reactive spaces, they get attracted towards one another, and the result the formation of the product. So when you come to a simple organic reaction, that explanation we call as the mechanism in organic reactions. So many type of reactions are there. Some reactions are replacement reactions. In some reaction addition take place. In some reaction decomposition take place. All these things that take place during the reaction. So different reactions are there. So those how that mechanism, the imaginary hypothetical explanation with logic, scientific background, that we call as the mechanism. So we'll have then what happens? So what happens during chemical reactants? Reactants, they form in a chemical reaction. Reactants form the products. We have the reactants react to form the product. So what are the? So one substance is there. A is a substance, and to that B is added, and this A and B they react. They produce this product. Product is produced. So then what happens here? So this B, we are adding it. It is called as the attacking agent. Attacking agent, or they call as we can call also a reagent. We can call that as a reagent. And this A, which undergoes chemical change, that is called as a substrate. That is called as the substrate. For example, that is substrate. The compound reacts with an attacking agent or reacts with another reagent, and it forms the product. It forms the product. So this is taking. So this is the chemical reaction taking place in organic compounds. For example, you take simple example. I take the methane. We have methane. This methane reacts with chlorine in presence of ultraviolet rays to produce methyl chloride and HCl. Methyl chloride, and so these are the reactants and these are the product. So here methane is the substrate. Methane is the substrate, and the chlorine is the reagent or attacking agent. It attacks methane, attacking agent, or that is called reagent also. Then this reaction is taking place, attacking agent. So we get the product. That means what is going on actually? What is going on? This is methane. In methane, the carbon atom is bonded to 4 hydrogen atoms covalently, and in chlorine, the one chlorine atom is bonded to another chlorine atom covalently. So what is happening? Then one covalent bond is breaking, and this covalent bond is breaking. So then this one chlorine comes, joins here, and hydrogen goes, joins there. So it is happening. So what is the cleavage of a covalent bond take place? The cleavage of this attacking agent also undergo change. And what has happened? A new bond is formed. So this forms what? This produces the reaction intermediates. We get the probable intermediate. Just I am writing a rough sketch, and it is H and Cl and Cl. So this H and Cl they combine to form a Cl, and this CH3 and Cl they combine to this. So we get the product CH3Cl methyl chloride HCl. So this position is, we are not seeing this position. We are not getting this. We are not knowing this position, and we got this product. So that is what is happening. This bond is breaking, and a new bond is forming between carbon and chlorine. So during a chemical reaction in organic compounds, the cleavage of the covalent bond take place to produce. These are the reaction intermediates. We call them as the intermediates. These reaction intermediates, then they react with each other and they produce the product. So the formation of, to understand a mechanism of organic chemistry, we have to discuss the fission of the covalent bond. How the covalent bond breaks. How the covalent bond breaks, the breaking of the nature of the bond, depending upon the bond, the nature of the bond, the breaking are different. So intermediate species will be different, and the product will be formed. So, and the reactions are of different types. There are substitution reactions, addition reactions, elimination, one may be eliminated and other is formed. For example, simple thing I am giving you. So, we say CS3, CS2, Cl, ethyl chloride. When treated with potassium hydroxide in presence of alcohol, we get the product. We get the product what? Ethylene, CS2 double bond, CS2 ethylene, and KCl and water. We get that CS2 double bond we get. So we get the CS2 double bond, CS2, and we get here the product we get HCl. You get the product as HCl in presence of water. So this is I am writing water, and this forms HCl and CS2. What is happening here? Now chlorine goes away, is eliminated. From here ethyl chloride, the chlorine is eliminated. What that happened? And you get this hydrolysis take place when you take elimination reactions, alcohol KOH, in presence of KOH, alcoholic KOH. So this you get CS2 double bond CS and HCl we get. So this what is happening here? So and we get another product is KCl and the other product is water. So one hydrogen goes from this place, joins with OH. So that means OH gets separated, K becomes, and you get ethylene, KCl and water. So how this is formed? So this reaction is chlorine. This is the substrate. This is our substrate, and these are our attacking agent or reagent. Attacking agent, or this is also called as reagent. And we get so this reaction is different from this reaction. What we get from a saturated compound, we get an unsaturated compound. And here one chlorine is gone, one hydrogen is gone. So this reaction is called the elimination reaction. This reaction is called replacement reaction or substitution reaction. Or if you come, there is addition reaction. When you take ethylene, treat with HCl. All reactions are not different. So if you take ethylene, another example I am giving you, we take ethylene, CS2, double bond, CS2, and we add HCl to this. The moment we add, this bond breaks. So here is a sigma bond, and this bond is a pi bond. The pi bond breaks, and we get here CS3, CS2, Cl. We get the product. Here ethyl chloride, you get the product. How this is formed? This do not take place like this. The path is very complex. So does not take very simple way, it is not taking place. There are some intermediate positions that come, there the reaction is taking place. So explanation of the such chemical reactions taking place in organic chemistry, that is called our chemical mechanism of organic reactions. So during this, to explain this mechanism of chemical reactions, there may be a displacement of electron take place, or the fission of the covalent bond occurs. Two things may occur. The fission of the covalent bond occurs. Here the fission of the covalent bond took place. And a new bond is formed again. So there may be a fission of the covalent bond, or maybe be displacement of one by the other taking place. So to form the reaction intermediates. So how this happens? So there are different theories, different type of theories are there. There are some reactions we will discuss, that is called, which depend upon the electron displacement. Then will come the reaction intermediates, and if two things we understand, then that will explain us the nature of chemical reaction. Different type of chemical reaction can be explained. All this total thing that comes under a topic called mechanism of organic chemistry. We have read already alkane, alkene, alkyne in our first year, 11th class. Now in second year we are reading alkyl halide, alcohol, aldehydes, ketones, both in aromatic and aliphatic compounds. So how these reactions are taking place. So to understand this, we have to understand the theories which are basing on electron displacement and the theories which are basing on the fission of the covalent bonds to form the reaction intermediates. Today I am going to discuss the reactions involving electron displacement or theories which explain us the electron displacement. So we will go to this. So the first thing we'll come discuss today in our class, the theories explaining the electron displacement of covalent bonds, electron displacement of covalent bonds, which lead to the formation of the reaction intermediates, and we get the product. So there are three theories, they are there. One is called inductive effect. Inductive effect. This is very important, which explains many facets. And second is electromagnetic effect. And third is resonance. And the fourth is hyperconjugation. So this resonance is also known as mesomeric effect. Mesomeric effect. So very important is these three, which are called inductive effect, electromagnetic effect, and resonance. Most of the compounds where there is a double bond, unsaturations are there, and there are conjugate system, there resonance will be playing very important role. And where there is a dissimilarity in a molecule, the atoms are bonded having dissimilar electronegativity, there the inductive effect can explain us. And where there is a pi bond in the molecules, and that can be explained by this electromagnetic effect. So first I will discuss today the first inductive effect, then I'll go to electromagnetic effect, then I'll go to resonance. Now comes inductive effect. What is this inductive and effect? Effect means what? Suppose a thing take place and change taking place. A change took place. That change is called the effect. Effect of the storm. Suppose the storm comes. Before the storm, you look to a place. You observe a place. Very cool, calm, quiet, everything is stable. The moment storm took place, now you will find some trees are uprooted, some roofs they have been broken, somewhere you have found roads are disrupted, the electric poles are dismantled, all these. So this is the effect of the storm. That is called effect of the storm. So here effect, that is the thing, what change occurring, that change, explanation of the change occurring due to what? Inductive. What type of change it is? Inductive. What do you mean by the word inductive? Comes from the word induction. It comes from the word induction. Suppose we have an iron. We have an iron. We know it is a magnetic substance. The moment we take a magnet and keep in front of the iron, then iron is attracted toward the magnet. So the displacement of the iron takes place towards the magnet and they get joined. Now when you are pulling one from the other, we are to exert a force. We are to exert a force. Now if we take another iron and keep in front of the iron, then this iron, first iron, will attract the second iron piece. Then you take out the magnet and keep two iron pieces. They will not attract each other. They will not be attracted towards each other. But the moment you keep a magnet by the side of iron, that iron is getting attracted towards the magnet because iron is a magnetic material and there is a magnetic force develops. So the iron is attracted toward the magnet and goes to the magnet. The moment we keep another piece of iron, that iron is attracted by the iron. Iron is not attracting another iron, but in presence of a magnet, the iron attracts another iron. And at that time, so what is this iron? The first iron behaves as a magnet. Behaves as a magnet. And this theory, phenomenon, is called induced magnetism. The force with which a iron is attracting another piece of iron in presence of a magnet is called induced magnetism. Induced. So the quality, the property of a substance changes in presence of another substance. So that change is called induction. That change is called induction here. So here the same thing happens in a molecule, in organic compounds, and we are going to discuss that. What is that happens? Now, what are organic compounds? The organic compounds are the covalent compounds. What is that covalent compounds? The combining atoms are bonded to each other by covalent bond. What is a covalent bond? A force of attraction which arises due to contribution and sharing of the electrons. When it takes place, when the atoms of the combining elements are in need of electron, they contribute electron, form shared pair of electrons, and those shared pair because of this contribution and sharing of electrons, for the completion of octet, a force of attraction develops between the combining atoms, resulting a new bond. That bond is called covalent bond. So in a covalent molecule, it is supposed that the one atom gives the carbon atom has 4 electrons, and so this and when you come to this another hydrogen atom is here. So here is a hydrogen atom, here is a hydrogen atom, the 4 hydrogen atoms are there. So carbon wants 4 electrons to be octet. So what is this? So this carbon gives 1 electron, hydrogen gives 1 electron, this they give electron, then they give electron, and they give electron, the molecule is formed. So we get this is a covalent bond. So this is a covalent molecule now. This is a covalent molecule. So these bonds are what? Purely nonpolar bonds. They are purely nonpolar bonds. So this was then explained according to atomic orbital theory or molecular orbital theory. The covalent bond is formed due to the overlapping up of the atomic orbital. These atomic orbital, they overlap to form a molecular orbital. The electron cloud of the molecular orbital is equally distributed between the combining atoms. So when you come to a molecule, in a normal molecule, when you come, so this is the carbon atom, and when it is bonded to another carbon atom, say, so this here there is both, there is no the carbon atom and there is no, this bond is a covalent bond. Means what? Here the carbon, the orbital, atomic orbital of hybrid orbital of carbon is overlapping with the hybrid orbital of another carbon, and they form a molecular orbital between the 2 carbon. So you form this the electron cloud. This is a molecular orbital, and this molecular orbital is there, and this is a bond. This is the representing the bond. Or when you have a carbon atom is bonded to a hydrogen atom. So there is a carbon atom is bonded to a hydrogen atom. Means what? This carbon atom, 1 electron cloud or sp3 hybrid orbital overlaps with s orbital of hydrogen to form the covalent bond. So what happens? So this is the carbon atom, and this electron cloud is equally distributed between them. This happens. So there is no difference of the electronegativity of carbon is 2.5 and the electronegativity of carbon is 2.1. What is electronegativity? The electronegativity is defined as the force with which a pair of the covalent pair is attracted by the atom of combining elements. So there is no difference of much difference of electronegativity, 2.5, 2.1, difference very less. So this electron cloud is equally distributed between the carbon atom and hydrogen atom. All organic compounds are hydrocarbons or derivatives of hydrocarbon. Now the moment we go to a derivative of hydrocarbon, what will happen now? If you come to a derivative of hydrocarbon, so when this carbon atom is bonded to X, a group. So this is an atom or a group, whatever it may be, is bonded to X, where electronegativity of X is more than carbon. We are coming to a molecule where the carbon atom is bonded to an atom of higher electronegativity of this. So then what will happen? So what is the supposed to be? We supposed to be what? This electron cloud should be equally between them. But it will not be like this. It is expected. It is expected to be like this. Like here, but it will not be like this. What happens? This X is more electronegative than carbon, means electron attracting power of X is more than the electron attracting power of carbon. The electronegativity is defined as the force with which a pair of electron is attracted by the atom of an element in a covalent molecule. So this pair of the electron cloud, now what will happen? Will be polarized towards X. So it will go more towards X. It will go more towards X. That means the electron density at X increases. Electron density at X will increase because its electronegativity more. So here what was supposed in a normal carbon hydrogen, what happens? Here 0 and here 0, electron density equal. But what is happening there? There the X is more electronegativity than carbon. So in reality, what happens? In reality, what happens? The electron cloud is more attracted towards X. So that means X is more nearer to electron pair. So it will have a delta negative charge, and carbon is away from X, so it will have a delta positive charge. It will have a delta positive charge. A fractional negative charge the X gets and the carbon gets. So, and the bond which was purely covalent will be no more. What is happening actually? It is here. What is happening here? The electron cloud is going towards X. As a result, X gets delta negative charge, carbon gets delta positive charge. So this bond now becomes partially polar, and the bond becomes reactive. Interested to take part in a chemical reaction. Now when you come to another molecule, this X carbon is bonded to Y, where Y is less electronegative than carbon. Means carbon has more electron attracting power than Y. So this electron cloud, which was supposed to be like this, will not be like this. What will happen? As a result of this, what will happen? This electron cloud will be more polarized towards carbon. The electron cloud is more polarized towards carbon. The electron density at carbon increases and at Y decreases. So since decreases, it will get a delta positive charge, and since it increases, it will get a delta negative charge. So this bond, now what is happening here? This bond, which was purely covalent, will not be covalent. Here delta negative charge and delta positive charge, and we will have a like this. So two poles are existing. So this is a dipole and this is also a dipole. So polarity is there inside the molecule. So induction of the polarity in a covalent molecule, induction of the polarity, partial polar character to in a covalent molecule, when the carbon atom is bonded to an atom of higher electronegativity or bonded to an atom of lower electronegativity, is called as inductive effect. As the polarity is induced, as fractional positive charge, negative charges are induced when the carbon atom is bonded to an atom of dissimilar electronegativity. The covalent bond is not a purely covalent bond. The covalent bond is no more a nonpolar bond. It gets a partial polar character. The covalent molecule is not a nonpolar molecule. The molecule exhibits dipolar character. The molecule exhibits dipolar character, and the molecule forms a fractional positive charge, negative charge, and here fractional negative charge and positive charge in the molecule. So such a phenomenon of induction of partial polar character into the molecule due to permanent polarization of the electron cloud when the carbon atom is bonded to an atom of dissimilar electronegativity is called as inductive effect. So this is a very important happens because you come to alcohol or COH bond. If you come to aldehyde, we have same oxygen atom, carbon atom. In most RNS2, their carbon atom is bonded to nitrogen atom. RCOOH, where you have the COH group is bonded there. So these are the negative groups, they are bonded to the carbon atom. So all these molecules, the reactions taking place because of this type of phenomenon will be occurring in them, and that is the reason if you have to understand what is this inductive effect, what are the different types of inductive effect, what are the characteristics of inductive effect, what this inductive effect explains such about the chemistry of a chemical compound, we will be discussing in our next class.